In the previous explanation, we learned that pressure in gases is created by gas particles repeatedly colliding with the walls of the container that holds them. We also saw that we can increase this pressure in several ways: by increasing the temperature, which makes particles move faster, by increasing the number of particles, which results in more collisions, or by decreasing the volume of the container, which forces the particles into a smaller space, also leading to more frequent collisions. This last point brings us to an important relationship: pressure and volume are inversely proportional to each other. In simple terms, as the pressure increases, the volume decreases, and vice versa. This means that for a fixed amount of gas at a constant temperature, the value of pressure multiplied by volume always remains the same, and this forms the basis of the equation pressure multiplied by volume is equal to a constant. Let us consider a practical example to apply this relationship. Suppose we have an unknown gas that occupies a volume of 1.5 cubic meters and is under a pressure of 100 pascals. If this gas is then compressed into a smaller volume of 0.3 cubic meters, and we are asked to calculate the new pressure, assuming that both the temperature and the amount of gas stay constant, here's what we do. We start with the equation pressure multiplied by volume is equal to a constant. We multiply 100 pascals by 1.5 cubic meters, which gives us a constant value of 150. Now, in the new situation, the pressure multiplied by 0.3 cubic meters must also equal 150, so we divide 150 by 0.3 to find that the new pressure must be 500 pascals. This tells us that compressing the gas into a smaller space caused the pressure to rise to 5 times its original value. There is another method to solve this kind of problem that many people find easier. Since the constant value remains the same in both states of the gas, we can simply say that the initial pressure multiplied by the initial volume is equal to the final pressure multiplied by the final volume. This gives us the equation pressure 1 times volume 1 is equal to pressure 2 times volume 2. So, in this case, 100 times 1.5 is equal to something times 0.3. Rearranging the equation and solving it gives us the same answer of 500 pascals. Let us try another example. Imagine we are preparing for a dive, and we take 1,800 liters of atmospheric air and compress it into a 12-liter gas cylinder. We are asked to calculate the pressure of the air in the cylinder, given that the temperature stays constant and that atmospheric pressure is 101 kilopascals. At first glance, it might be slightly tricky to decide which numbers go where, but the key is to notice that the original air, 1,800 liters of it, was at atmospheric pressure, which is 101 kilopascals. So, using our same equation, pressure 1 times volume 1 is equal to pressure 2 times volume 2, we multiply 101 by 1,800, and set that equal to the unknown pressure multiplied by 12. Doing the math, we divide the product of 101 and 1,800 by 12, which gives us a final answer of 15,100 kilopascals. That means the air, once compressed into the cylinder, is now under a significantly higher pressure, and importantly, the units remain in kilopascals because we use kilopascals in the original pressure value. And with that, we have reached the end of this explanation. Hopefully, you found it useful and understandable, and we look forward to seeing you again in the next session.